hello physics. One thing, especially in AQA, is they try to trick you with this language, right? Sometimes they'll write, what is magnetic flux? Sometimes write, what is the magnetic flux linkage? Sometimes they'll just say, what's the induced EMF? And all the formulas look so similar. Be careful, if it just says magnetic flux, it's just B times A. Okay, what B is your magnetic flux density. Okay, you saw B from your GCSEs. Because remember, in GCSE, you did Fleming's left-hand rule, F equals BIL. Remember, magnetic flux density. So, for example, if I have these field lines or I have these field lines, clearly this side has got a greater value of B, of magnetic flux density, because there's more field lines in a concentrated area, right? They're more dense. So that's magnetic flux density. It just tells us how many field lines we have passing through a unit area. So magnetic flux is just our magnetic flux density times by our area. So let's say I've got a circular coil. So there's my circular coil. There's my circular coil. Clearly the magnetic flux for this coil is much higher because the value of magnetic flux density is much higher. Okay? Magnetic flux linkage has got N in it. So magnetic flux is represented by that symbol, which is B times A. We recognize it because it's also used for a work function in paper 1. Magnetic flux linkage is N times the symbol is N times B times A. So the only difference is, now we're multiplying by N, as the number of turns of coil. So let's say instead of having one loop of wire, maybe we have 100 loops of wire. So I've got 100 loops of wire, or I've got 100 loops of wire. So it's the exact same math, you just multiply by 100. You multiply the number of loops of coil. The next one is your just EMF. And what that is anything divided by times rate. It's the rate of change of your magnetic flux linkage. Okay, make sure you don't say magnetic flux, it's magnetic flux linkage because you have that N in there. Okay, something you need to know about magnetic flux linkage or magnetic flux, because of this question down here, magnetic flux linkage is always going to be a maximum when the normal is parallel to the field lines. Other people learned that as the plane of the coil is perpendicular. It's just the same stuff. I think normal is easier, okay? Because I just think it's always easier to find where the normal is based on that waves topic. So let's say we have our field lines, and let's say it's got some coil, and let's say there is my normal, okay? So it's going to be a maximum when the normal is parallel. So to get that normal parallel, we have to shift it. So let's say that normal is that many degrees beneath the field line. So I need to shift it up through that angle. Remember, anytime you go through the angle, it's always cosine. So that's why you always see it's BAN cosine of theta, because if it's tilted at an angle, to make it maximum, you want the normal to be parallel to the field lines. Another way you might say that is the plane of the coil. The plane of the coil is just perpendicular to your normal.